At some point, you've probably caught an AI confidently telling you something completely wrong. Maybe it cited a study that doesn't exist, named a person who never wrote that paper, or gave you a date that's off by a decade. It didn't hedge, it didn't say it was guessing, it just told you with the same calm certainty it uses when it's right. This isn't a bug that gets patched in the next update. It's not carelessness, and it's not the model being lazy. It's a structural consequence of how these systems work, one that the field has been wrestling with since the beginning and hasn't fully solved. Here's why. To understand hallucination, you have to understand what a language model is actually doing when it responds to you. It is not looking anything up. There is no database of facts it queries, no encyclopedia it searches, no internet connection it reaches through during a conversation. A language model is a very large mathematical function, billions of numerical weights, that was trained to predict what text should come next given the text that came before it. During training, the model read an enormous amount of human-written text, not to memorize it, to compress patterns from it into those weights. The result is something that can produce fluent, plausible-sounding text about almost any topic, because it has seen how humans write about almost any topic. But plausible-sounding and accurate are different things. The model optimizes for the first. The second is not guaranteed. This is the root of hallucination. The model has no mechanism to distinguish between, I've seen a lot of evidence for this, and I'm pattern matching what this kind of answer usually sounds like. It produces text that fits the shape of a correct answer without access to ground truth to check against. Think of it this way. Imagine someone who read every academic paper ever written, absorbed the style, the vocabulary, the structure of citations, the kinds of conclusions researchers draw, then lost access to all the original texts. If you asked them for a citation about neuroplasticity, they could construct one that looked exactly right. Plausible author names, plausible journal, plausible year, plausible title. It would have the shape of truth. It might not be truth. That's the citation hallucination problem. When you ask an AI for sources, it generates text that looks like citations, because it has learned what citations look like. There is no librarian checking whether that DOI resolves to a real paper. The model doesn't know the difference between generating a real citation and generating a very convincing fake one. To it, they're the same operation. What makes this worse is the confidence. Human experts usually know when they're at the edge of their knowledge. They hedge. They say, I think, or you should verify this. Language models are trained to be helpful, which often means being direct. The result is outputs that sound authoritative whether or not they should be. There's another dimension worth understanding. Hallucination isn't random. It tends to cluster in predictable places. Ask about a real, well-documented topic and the model usually does well. There's a lot of reinforcing signal in training data. Ask about something obscure, niche, very recent, or about a specific detail, precise date, an exact figure, specific paper, and the model is operating on thinner signal, and it still produces confident text. But the gap between confidence and accuracy widens. This is why hallucination is particularly costly in certain domains. There's a well-documented 2023 case where lawyers submitted AI-generated legal briefs containing citations to cases that simply did not exist, fabricated docket numbers, invented party names, fictional judicial opinions. The citations looked real because the model had learned the precise format of legal citations. It had no idea the underlying cases were imaginary. Medical contexts carry similar risks. A model might correctly explain how a drug works while subtly misstating the dosage range. The surrounding explanation is authoritative enough that the error reads as a detail rather than a failure. And it's the specific detail that matters most in medicine. The pattern is consistent. The model is most reliable when the topic is well documented and the question is general. It's least reliable precisely where expertise matters most. In the narrow fact, the specific figure, the edge case that separates a correct answer from a plausible sounding wrong one. The obvious question is, why not just train the model to say, I don't know? The answer is that you can to a degree, but it introduces a different problem. A model trained aggressively to refuse or hedge will become less useful. The uncertainty is often genuine. The model doesn't know whether it knows something or not. It has no direct access to a confidence score that reflects its actual accuracy. What you get is a model that says, I'm not sure about things it actually knows well, and still occasionally hallucinates where it's been reinforced to sound confident. Fine-tuning helps. Reinforcement learning from human feedback, Where human raters reward accurate, appropriately hedged responses and penalize hallucinations, measurably reduces the rate, but it doesn't eliminate it. The model's underlying architecture is still a pattern predictor. You can shift the distribution of what it outputs. You cannot replace its fundamental mode of operation. One of the most effective practical mitigations is retrieval augmented generation, or RAG. Instead of relying on the model's weights to recall facts, you attach a retrieval system, a document store, a database, a search index. When a question comes in, the system first retrieves relevant documents, then passes them to the model as context. The model's job shifts from recalling facts to reading and reasoning over provided text. This works well because language models are genuinely good at reading comprehension. Given accurate source documents, they can extract, synthesize, and explain with high fidelity. The hallucination risk drops significantly because the model doesn't need to invent, it just needs to read. But RAG isn't a complete solution. The model can still misread the source, confuse details across documents, or fill in gaps the retrieved text doesn't cover. And for tasks that don't involve document retrieval, code generation, reasoning, open-ended conversation, there's no document to retrieve from. The model is back on its own. Tool use is another approach. Let the model call a calculator for math, a search engine for current events, a code interpreter for programming tasks. Each tool offloads a category of error-prone generation to a reliable external system. These help. They also increase complexity, latency, and cost. Here's the honest state of the problem. Hallucination rates have dropped substantially over the last 3 years. The best current models hallucinate far less than earlier generations. But the rate is not zero, and for tasks where accuracy is critical, medical information, legal research, financial details, citations, and published work, that's a serious limitation. Here's the mental model worth carrying forward. A language model is a pattern completion engine. It learned the shapes of human knowledge, how arguments are structured, how citations look, how explanations flow, and it can reproduce those shapes with impressive fidelity. But it has no independent access to truth. It cannot look at what it just wrote and verify whether it's real. This changes how you should use it. For tasks where errors don't matter much, brainstorming, drafting, summarizing your own documents, the hallucination risk is manageable. For tasks where a wrong date, a fake citation, or a misremembered figure has consequences, you need to ground it. Provide the documents, use retrieval, verify the outputs. The goal isn't to stop using these systems, they're genuinely useful. The goal is to understand what they actually are. Not a search engine, not a database, a very capable text predictor that works best when you give it something real to work with. If this kind of systems level thinking about AI is what you want more of, subscribing is how you get the next one.